Hi, welcome to using law of sines and cosines. This is going to be how to use law of sines and cosines. I don't go into the mechanics of why we get these relationships between opposite sides and angles, or between other sides and one angle, as in the law of cosines. So if you're interested in that, then there are some resources out there for you to look into. But I'm just going to hit the bare bones on how to use these things and where they're appropriate to be used. So if we look at law of sines, and I've drawn, there's quite a bit for you to put on your page for notes, which is going to have practice right beneath it. But I'm using this diagram of a triangle with its opposite sides and angles labeled. It's that right there is an isosceles triangle where two sides and those corresponding angles are the same, but it's meant to be. Imagine this is an oblique triangle, which means it's not a right triangle, it's not an isosceles. It just has all sorts of sides and angles that don't follow any specific pattern, or they don't have a nice right angle in them. So this oblique triangle is going to be our little guide for how the law of sines and cosines works. So if you get lost, you can reference that. It's important for the law of sines, which is what we'll talk about first. For the law of sines, that you are comparing at least one angle that we know with its corresponding opposite side that we know. So we would have to know angle A and side A in order to use it, along with let's say angle B. So this would be an angle side case, for example. If we want to use it in a different way, then we could know two sides and then one of those sides opposite angles. So we could know B and C, and we'd have to know, let's use these colors, we'd have to know C's opposite angle, the angle opposite C, which is we call C as well. So in that case, if we just look at that, the algebra that's happening here, we are just going to be isolating a variable, because we don't need to know what A is. We could figure out what A is if we know two angles, but once we have just part of this relationship, so if we have just this equation to work off of, then we only have one variable to solve for, and we'll use an inverse trig function to do that. So a lot of this is right triangle trig, which you've probably seen before in some form or fashion. It's just a little bit I don't know, more in pre-cal. So what I wanted to point out, and what I hope you got from that, was we're using angle side and side angle side for law of sines. So this key point right here is important. And another, like, I know if, and this is like your given information. So if you're given angle, and then another side that's opposite to one of those angles, then that's when you would use law of sines. Side does not work. If you're given three sides, don't use law of sines. And we also try not to use side angle for law of sines, because there's multiple solutions possible. There's also no solutions possible. So in order to avoid that, we use the law of cosines, which, as you can tell, is a little bit more involved, but it's basically, if you look at my conditions over here for what we're given, this is what we're given, then it's always going to work. Angle, side, you have to work a little bit more for, and I'll explain why in a second. But let's say we want to use, let's say we're given, let's do side angle. We're given B, C, and then, oh, I also don't have, almost forgot. Angle, side angle also works here. My bad. I should put it down here as well. Anyway, so let's look at law of cosines. B, C, what else are we gonna be given? Let's be given, yeah, angle B. So if we know our angle B, C, and side C, then we want to use one of these equations for law of cosines that is going to utilize all of these variables except one. So we want to use the law of cosines that has angle B in it. So we're going to use this one right here for this type of equation. I know B and C, so I can mark those. But I need to figure out what A is. So there's some algebra that we can do to determine what A is, and you'll see that play out as we work through some of these problems. But essentially, the algebra is a little bit more involved with cosines, but it always works. And we'll see some of the situations that you may want to use law of sines or cosines. I've also, in the directions, said that you have to use law of sines in some of these, and you have to use law of cosines in some others. I'm sure when you practice some of these, maybe in class or on your own, you'll get to see which one you favor more and why you may or may not like some of those. So with that, let's look at number 3. So number 3, we're using law of sines, and we want to find side AB. So we're going to call this little c, which is also known as AB. That's this length. So if I want to find side C, I know, and this is probably how you want to start these off, just by writing what you know. Angle B is 88 degrees, angle C is 54 degrees, and side C is unknown, but we do know side B. B is 26. So we can start to make our relationship happen here. So we'll have sine of B, sine of 88 degrees, so we'll just use 88. And we have to use the side that goes with 88 degrees, and that's 26. And that's equal to sine of 54 over what we don't know, which is C. So we've got to evaluate this left side and do a little cross multiplication to determine what this value is. So I'm going to do that, and then I'll see you on the other side. Right, so this is what I got for my answer. I got 21.047. Nearest tenth would be just 21.0. And it's really important when you evaluate these to leave the solution, the answer, until, like, leave it not worked out until the very end, so that when you plug it all into your calculator, like if you don't have a calculator, Desmos actually isn't really a great thing to use because it only takes degrees in radians. So if you have to use an online calculator, just use the one that Google provides and make sure you have selected, I'll show you, make sure you've selected degrees here in the top left. That's going to get you, and I'll show you what it looks like. Well, no, it won't swap, but make sure degrees is highlighted, and it's very slight, but that will definitely change your answer. And we don't know too much about sine and cosine and how that stuff works, but the ratio for sine is going to be important, and it has to be between 0 and 1. So I'll explain more about that when that comes up. But for now, let's try 7. For 7, we're not given a picture, so we have to draw that. And another thing that we have to notice is we are given, let's see if we can see that. There's 95 degrees, so that's B. We are given the wrong case for this triangle. So we are given angle, side, side. And that's not going to be appropriate for how we use sine. So for number 7, if we were going to use, let's set it up. We would have sine of 95, and 39 goes with that. That's equal to sine of A over 40, and we try solving for this, which I'll show you how we do it because it is a little tricky. I'm just going to move my 40 over here, so I'm going to have 40 over 39 times sine of 95 is going to be equal to sine A. And you might be wondering, how do we get to that A? Well, we have to take the inverse, let me just move this. We have to take the inverse sine of each side. So we would have to undo the sine operation of each side. And this side, this right side, would have to be undone. Oops. With inverse sine. And so that should be a button on your calculator, and on Google. But as you can see, if we have sine and we take the inverse sine of it, then we should just be left with A, if that's truly how inverses work, which it is. So A should be whatever this number is. So I'm going to plug all of that into my calculator, and I'm going to do that real time so you can see. I'm going to try to put it on both. That's not it. I'm going to try to put it on everything so you can see what I'm doing. Let's see. There we go. So we'll clear that. So I'm going to do inverse sine, which looks like Google doesn't have. So that's cool. Well, let me find something that does. Okay, so first result, Desmos has a nice calculator. If we just look up their scientific calculator. I forgot about that. That's good. So I'm going to put in inverse sine of 40 divided by 39, and then times sine of 95. Making sure that degree is highlighted because I'm using degrees. And I press enter. So I didn't get a number for that. And that's because I didn't get any value for that. That's because this number right here is greater than 1. And when we put in a ratio into inverse sine that's greater than 1, it doesn't work. So suffice to say, this is going to be undefined. And remember, this was a side-side angle relationship, so it's not going to be the way to solve this triangle. It's important that we figure out how to use which rule, either law of sines or law of cosines. Law of cosines will also tell you undefined here, in case you were wondering. So this triangle just doesn't exist. It's describing a triangle with sides that don't meet up, is what it's saying. All right, so I'm gonna do these 9 and 10, 11 examples on my own, and I'll show you the results, and then I'll see you on the other side of the video. All right, so here we are. I've done some calculations, and on number 9, I was able to find that B, or side AC, was equal to 41.99, and really I just had to pick out the one that used, which they all do, but I wanted to pick out one where I was solving for B, because that's the side I was missing. So I just used A, which is this side, and then C, which is 19, in their respective places in the formula, and that's how I got my answer. So that one's just a pretty straightforward to evaluate that problem. Now 11, and likewise I forgot to mention 7, but they are solving each triangle, and when you solve the triangle you have to find all sides and all angles. So on this one you have to find A, B, and C, because they're the only things that are missing. And on this one, I just solved for A. I'll let you solve for B and C after that. And don't forget that the rules for triangles haven't changed. Once you know 2 of the angles, you can just subtract them from 180 degrees to get the last angle. But I found one of those angles for you, and that's 54.1. And to do that, I did have to use the inverse cosine function to undo the cosine operation, which I found at the very end. So you can look at my work there and see how that was done. It's all about isolating variables. So I'm sure your teacher will have you either do all of these or most of them, but for my class, so for the students who watch this, I'm just going to ask that you complete, let's see, 4 of the three of the law of sines problems and 3 of the law of cosines problems. So you can pick which ones that you want those to be. I recommend picking one from each. But there you have it. Thanks for watching, and I'll see you later. Bye.